All right, so we're going to talk about nonlinear systems today. So if you recall back from Math 1, you did a linear systems, you did the eliminations and substitution, and then graphically. We are only going to be focusing on graphically, which is going to be awesome because we can use Desmos, which is going to make this lesson easy peasy, okay? So a linear equation is one in which one or more of the terms is a power no higher than 1, okay? And that's what you've been using. And then we're going to throw some quadratics. So a quadratic, just to refresh your memory on that, is one in which one or more of the terms is squared but raised to no higher power. So that's your ax squared plus bx plus c. Okay, so those are examples. I just want to refresh your memory because we've been talking about absolute values quite a bit. Okay. Let's see. All right, so solving nonlinear systems. A nonlinear system of equation is a system in which at least one of the equations is nonlinear. Okay, so that means one can be a quadratic and one can be a linear, and it's still a nonlinear system. Okay, your solutions depend on your nonlinear equation. Okay, so it's going to depend on, so if you have a linear and quadratic, how many solutions you possibly could have are going to depend on the quadratic. A solution in a system of equations so you'll hear a lot, and actually on the EOC it asks you, where does f of x equal g of x? That it just means on a graph, where do these two graphs intersect? So here is a quadratic. Now also a quadratic and an absolute value follow the same rules with nonlinear systems. Okay, so because we've been over the absolute value, it's the V shape. It's just like the quadratic, except it's a V shaped, has a different slope, but it's going to be the same considering nonlinear systems. So you can have a nonlinear system with a quadratic and a linear can be two. So you could have two solutions where it intersects twice. So let's see. So where it intersects twice. You can have one where it only intersects once, so that's only one solution. And then you can have it where they do not touch at all. See this huge gap? They do not touch at all, so there's no solution. Okay, so if your two graphs do not intersect, you're going to put no solution. Okay? All right, so we're just going to start some examples, and I'm going to pull up Desmos. I'll show you the equation, and then I'm going to pull up Desmos, and we're going to talk about it from there. Okay? All right, so when we look back at the PowerPoint, it says how many solutions does this system of equations have? Okay, so it doesn't want to know what the solutions are because it can ask you so many different types of ways with these systems of equations questions. So this one, so really important you read them. Okay, so it says how many solutions does the system of equation have? It didn't ask what the solutions were. It just said how many. So when I come to Desmos, I'm going to type it in. Okay, and I'm going to type it in exactly how I saw it. It was, well, done. Let's see, which one is this one? Okay, so this is the square root one. So your square root, so you're going to do y equals, and the square root one is right here down by your ABCs. So it's the square root of x plus 3, and then I'm just going to use this because it's getting on my nerves. X plus 3. You get out from underneath there, and then it's going to be a minus 2. Your second equation is y equals, it's the absolute value. It's going to be the absolute value of x minus 2. X minus 2. We're going to close the absolute value, and then it had a plus 2. Okay? So I want to know how many solutions. Well, remember we looked at the slide previous to this one? They have to intersect to have a solution. So, do these two graphs intersect at all? No, they don't. So, we would go back here, and this would be a no solution. Okay, this is a no solution. They do not intersect, they do not touch. There's no solutions here. Okay? So the next one says, these two equations says, what is the y value when f of x equals g of x? So where these two equal is where they meet. Because when you equal with somebody, you're like meeting with them. Okay? Same place, equal. So it wants to know what's the y value. It doesn't care about the x value, it wants the y value. Now, the great thing about Desmos is with Math 1, you would have to solve this equation for y before you could enter it into your TI-83. But Desmos, you can type it in just how you see it and find the intersection. So we go back here, and we're going to type it in exactly how we see it. So it's negative 1/2. So we're going to come, just suffer for a minute. Negative 1/2 negative 1/2 x plus 4 x plus 4, and then we can put the y in front. I forgot the y. Sometimes you don't need the y, but sometimes you do, so it's a good habit just to go ahead and keep typing y equals, okay? It's just, it doesn't hurt it. It doesn't hurt you to type the y, but it will hurt you not to type the y sometimes, okay? So 5x minus 4y minus 4y equals 12, okay? Now, you see where they intersect, but another thing you can do is you come over here and you just click on these, and the gray dot helps you appear. But you're trying to find where these two intersect, and you see right here, X marks the spot between these two. All you have to do is click on that gray dot, and what is the y value when these two equal each other? The y value is 2. Ta-da! So you would just say y equals 2. And there was no other intersection, okay? Because remember, linear is one solution, many solutions, which is the same line, and no solution. Okay, so that was one solution of y equals 2. All right, this one, it says, what are the ordered pair solutions to this system of equations? So it actually wants the ordered pairs. It wants where do these two graphs intersect, and what are the ordered pairs? So we're going to go to Desmos. Okay. The first one is going to be y equals x squared minus x minus 6. The next one is going to be y equals 2x minus 2. I know it's painful to watch me do this. Y equals 2x minus 2. Minus 2. Okay. All right. So where do these two intersect? You can move your graph around. Okay. And they intersect twice. One or a pair, just click on it, and you want that gray dot. Okay. Where they intersect, not where they cross the x-axis. Where do they intersect? Well, they first intersect at -1, -4. So one answer will be -1, -4. And then the other answer is going to be 4, 6. Okay? So those are my two solutions for this system of equation. Okay? All right. So now let's look at some problems. Other types of problems you could see with systems. Okay, so example 4 says the graphs of f of x equals x cubed minus 4x and g of x equals -2x, that's minus 4, are shown on the grid to the right. What can be stated about the real solutions of the equation? Okay, so what can we state about the solutions to where f of x equals g of x? Not solutions to the equation, but where do these two equal? Where do they meet? Well, they meet in how many places? They meet in one place, so they have one solution. It's because it says what can be said, so let's say it. So there's one solution. And then what is that solution? That solution is the ordered pair, 0, -2. Okay? So it has one solution, and that solution is -2, 0. Excuse me. -2, 0. Okay, so it has one real solution, and that is -2, 0. Okay, so it's another way we could ask you about systems. Here's another one. It says the graphs of y equals absolute value of x plus 1 and y equals absolute value of 3x minus 3 are shown on the grid to the right. what is the solution when these two equations equal each other? Where do they meet? They meet twice. They meet right here. And just guesstimate it. It looks like it's going to be 0.5 and then 1.5. Okay. And then the other one looks like it's about right here, which is going to be 2, 3. Okay, and those are your solutions. All right. So now I also want to do some questions you're going to see like on the EOC or Study Allen or Delta Math. Okay, so here it says, so here's a screenshot of a Delta Math that you would see, and it says, what order pairs are the solutions of the system of equations shown in the graph below? So again, when you see solutions to the system of equations, that means you want where they intersect. Where do they meet? Meet, touch, whatever. Okay? So where do they touch? That is what that means. Well, touch is right here at -4, 1. -4, 1. And then it also meets right here at 1, 6. Okay, and that would be it for your answer for that Delta Math. Okay? All right. Your next one is going to be something you could see on a Study Allen question. Okay, so I wanted to do this one. It says, let's do a snip so I can write on it. So it says that functions f of x and g of x are defined below. Determine where f of x equals g of x by graphing. So I want to know where these two equal, which means where do they intersect? Okay, so we're going to use Desmos. So 1/3 x plus 3. So 1/3 x plus 3. So we've got y equals 1/3 x plus 3. And then the other one is going to be absolute value of x plus 2 minus 3. And then minus 3. All right, just double check it real fast. Plus 2 minus 3. Okay, so where do these two meet? Right? Well, if you look, they meet right here on this one gray dot, -6, 1. But you've got two intersections, correct? So you're going to have two answers here. So when you go back, it's asking what is x? Well, I know I have two answers, so I can mark out all of them. And process elimination gives you the answer if you just know by looking. But my x's are -6 and 6, which would be A. Okay? All right. So the last problem I'm going to do with you is actually an EOC problem. Well, I thought I was already scrolled on it. Let's see. Whoops. Oh, man. It's not a long document. The computer's thinking a lot. Okay. Let's go. I'll get there in just a minute. Computer's really hot. Okay. Almost there. Good gracious. Here we go. Here we go. Okay, so two functions are shown below. What is the y value when f of x equals g of x? Okay, So I want to know what is the y value here. I don't care about anything but the y value where these two graphs meet. Okay, so we're going to pull them up on Desmos. Okay. So let's go to Desmos, and we have y equals 2x cubed. So y equals 2x. We got to cube it. And get out from it. 2x cubed plus 2x minus 3. Plus x minus 3. Minus 3. Okay. And then the next one is y equals negative 0.5. And it's an absolute value, so we need to pull up the absolute value of x minus 4. Okay, and it's closing the bar. I just want to make sure I did that right. 2x cubed. Okay, so 2x cubed. All right, so what is the y value when these two intersect? Right here, the y value is negative 1.75. So the y value would be negative 1.75. All right, so that are the many different ways you can be asked about the solutions to nonlinear systems of equations. Let me know if you have any questions.